Hello guys, hello, welcome one and all to today's brand new live stream. Today we are streaming the contest solutions of a whole different platform which is newly made from past 3-4 months. I'm not exactly sure, but it has literally covered the problems which were present, which were problems in the sense the actual problems that were visible in lead code as well as our code forces. So it is like, to be honest, I feel one of the most complete platform ever built. The name of the platform is Repovive. I don't know how many of you are aware of this. This is an awesome platform, to be honest. The questions are really good. Also, so today what we are gonna do is we are gonna uh, discuss about our today's contest in Repovive Career Starter Round 2. I actually liked a few questions in this, like in terms of the story. Also, like for example, the C question, Hannah's brain, and also the ice cream one. Basically, it was like a bit of, what do you say? Like we had to use a bit of brain more than the general or whatever the 4-5 standard algorithms we have in lead code. So basically, from my point of view, it was a really good storytelling for the questions, to be honest. Also, so yeah, I would recommend everyone, like every one of you, if you guys are interested to use this platform. So with this, we are gonna start today's contest review. First thing is, we'll check our first question, which is two waves. So two waves, a question by Amir Muhammad Shahrizail. I guess I read it properly. So it says that there is an infinite tape of cells numbered 0, 1, 2 continues. Two waves start at a time 0. The first wave starts from cell A and the second wave starts from cell B. A wave reaches a neighboring cell in exactly 1 second. More formally, the wave starting from cell X reaches cell Y at time x modulus of x minus y. Determine whether there exists a cell C such that both waves reach C cell at the same time. So basically, what we need to find here is if there is a wave which will reach another, like particular cell at the same time. For example, if both are reaching at the same time interval, for example, you take the time interval of 10, both are reaching at the same time. At the same cell, for example, take the cell as some x. So, how we'll just try to understand this question. In simple words, we can just analyze this like two people are standing in a grid kind of thing, like square tiles with position C A and B, and then at the exact same moment they start walking towards each other and they'll move one tile per time. So we need to find if they are gonna step on the same tile at the same at the same tile at the same point. For example, imagine if they are starting 4 piles apart. Let it be something like this, or I'll just take 2 because it will be difficult for me to draw. Fine. Okay, let's take those 4 piles. Here is Mr. A, here is Mr. B. Now they both start walking towards each other like this. Now what they are asking is it possible that they both will be on the same tile at same point? That is all as what is in the question basically. So if we just look at the question mathematically, Basically, it is a distance from A to C that should be equal to the distance from B to C. A to C should be equal to B to C. That's all as a whole this thing. So with this, if we just basic math, if we do, modulus of A minus C should be equal to modulus of B minus C. Basic math we are doing. So for C to exist, what is our rule? C should be the midpoint. Simple math. So how are we gonna calculate the midpoint here? C is equal to A plus B by 2. Like A plus B whole, this is not just B by 2. That is all. So if this is divisible, then A and B must share the same parity or whatever you call. Like both are even or both are odd. If one is even, one is odd, it's gone. So yeah. Now we'll just check the approach, basic how we did. Like I explained the approach almost. Imagine two starting points A and B. Actually there is no need to build any waveform or anything here. Simply we'll just take the parity check of their sum. So what we'll do is A plus B by 2 is equal to 0. If this is the condition, if this gives me a perfect integer, perfect int, in that case what is gonna happen is midpoint is gonna exist. Midpoint exists, which means my output is yes. And in the other case it's no. That's all. Else no. Simply else no. Just don't worry too much about the else case. Our output will be no. That's all. Simple question. So what is gonna be the time complexity and the space complexity of this? It's very easy. However hard, like however huge the number goes, the time complexity for calculating modulus will be always O of 1. So the time complexity will be O of 1 in this case. And the space complexity, if we go to the space complexity, we are actually not storing anything except some two variables, so it's just almost like a negligible. Or if you really want to mention, you can just mention it as O of 1, or you can just keep it as 0. We are just storing two variables A, B and mid if needed. I hope this is clear to everyone, guys. If anyone has any doubts, you guys can put it in the comment section or wherever you guys are comfortable. So if you guys are sure about the question, we can move ahead. We can move to our next question. And like if anyone wanna see the code, I'll just share the code. This is very basic code. As I said, this is all you need to know. Yes, if A plus B by 2 equal to 0, else no. That's all. 2 lines basically. Yeah. Moving on to our next question. I'll move to third question first. I like the third question, so I'm moving to the third question. Nothing like, I don't know how this got missed, sorry. This was an awesome question. Like I like this question, maybe because I'm too much into CPUs and GPUs. So I was actually reading this question while I was eating basically. I was trying to figure out as like I just went like I started the contest late. One of the main reasons why I lost a lot of ranking today is that I started it like very late. Before that, for almost A, B, C, D, I was just reading the questions and figuring out how I can code. And I tried to code with my mobile, but I don't know, like I code with Python, so the indentation was a bit screwed. So that's it. Now I'll just explain what this code is. Hannah's Brain by Ali Barikbin. So Hannah has n CPUs. The ith CPU initially has A of I cores. In one operation, she chooses one CPU with X cores and splits into two CPUs with positive integer numbers of cores Y and X. My Y and X minus Y, where X is greater than Y and Y is greater than or equal to 1. After performing some number of operations, Hannah wants all remaining CPUs to have the same number of cores. Find the minimum number of operations required. My honest opinion, the contest was amazing, but does deserve to be in the question B, to be honest. Like, we'll just see the constraints and all, like n lesser than 5000, A of I lesser than 5000. The reason why I said that is, if we look at this question, if we just read the question, what it says basically is, I'll just give you a simple example. Hannah's Brain. It's basically what mums do in a family where there are some equal number of, like there are some brothers or siblings. Like if there are 4 or 5 siblings, mother takes one chocolate and she cuts it equally and makes sure that every child gets the same. That is all is in this question, to be honest. So if we see that, right, basically what this whole question is saying, if we try to figure out, we need equal like the same number of the cores for per CPU at the end of the day, and it should be equal for all, and there should not be anything left. So basically what it is, if we just think a bit deep, it's just GCD or the HCF, the greatest common divisor, or whatever, the highest common factor, whichever you guys are taught with. So we'll just see how we can do this. For example, we'll take our target chunk size as K. Our K will be GCD of our A1 till our AN. That is all. But we just need to count the operations here. Like how many of our operations are there? Count operations. That is what is the major thing we are doing here. And every time one split is done, for example, this is the split done every time, the count will increase by 1. Like the total number of objects increase exactly by 1, not more, not less. So the final is basically like the number of splits, and like once we get our HCF or GCD, we just need to have what? A final objects, final total objects minus initial object. Why we are doing it? HCF gives us what? HCF is gonna give us the maximized K value, but then we are asked to find the number of operations required. Basically every single time one object is getting increased, so the total number of objects increased, or the total number of operations required for us is the number of objects that is increased, which is final minus initial. If initially there were 10 and Sorry, if initially there were 10 and our final is 20, it's basically we'll be having 10 operations were needed. Just given an example, I didn't check the whatever the test cases were there and all. I mean, I saw it during the contest, now I didn't see it. Now how to do it, I'll just explain you guys the approach, which I already did though. There's a bit systematic way, that's all. We'll take an array, we'll parse an array for initial CPU counts, initial CPU core counts, CPU this is, core counts. And then what we'll do is, we'll find the GCD of entire array. GCD of array, as I said earlier, A of 1 to A of n. This will calculate the total number of cores. Total cores, which never changes. This is never gonna change. Now what I need to do is, I need the final number of CPUs. This is our step 1. This is my step 2, and now in our step 3, what I need is my final. I need to calculate the sum of the entire array. So A of 0 to A of n, I need to calculate the sum. A of I will take. A of I to A of n, I need to calculate the sum. And this is the total number of cores. And again, this is never gonna change. This is always constantly remaining the same. Now, next step, what I'll do is basically we'll calculate the total number of GPUs by we'll calculate the final number of CPUs by dividing our total core by our target size. So what we'll do is, total CPU is equal to our sum divided by, we'll take a number g as our target size. Now final step is, as I said, we need to calculate total split. So to this, basically what we are doing is, one CPU per pile, right? Like per split, one CPU per pile basically. So total CPU minus n, where n is a starting number of our CPUs. This is gonna give me total splits. This is my output finally. That was all was this question. I'll just go to the code 1 second if you guys need it. So here is my code. Here is my code. We are taking the sum of the array. First we are calculating the GCD, and then we are taking the batch size, and then finally what we are doing is we are taking the sum of the array, and then we are dividing it by the batch size g. And finally my result is my output. That was the some final subtraction. After doing the subtraction of the initial number of CPU count, that is gonna be in my result finally. So this is, I just like this question because initially it might seem complex, but it's at the end of the day just HCF. I mean, honestly, just HCF. So what is the time complexity of this, anyone? Anyone in the chat, guys, what is the time complexity of it? Okay. So the time complexity of this is gonna be O of n log max of a. This is because we loop through the array with n elements exactly once, and we calculate sum using this thing, and then the rolling GCD is found. Also, we use Euclidean algorithm for finding rolling GCD. That will be like logarithmic time. So basically this is gonna be my final time complexity. What is my space complexity? Basically O of n directly. No need to explain, I think, because just an n elements array taken, that's all. Simple, very simple. Everyone will be super sure about what is. I guess this is clear to everyone, guys. If you have any doubt, please go on. Like, you're free to ask any doubts if you guys have it. Okay, this is O of n. Sure. So we'll move on to B now. Class photo groups. This is also a good question. I mean, honestly, today's contest storytelling, I'm repeating it. I liked it very much personally. So yeah, I would obviously appreciate what I liked. So what does this question be? We are gonna go to our question B. Class photo groups. Give me a second, guys. I'll just drink some water. Yeah. So, class photo groups by Amir Mohammad Shahrezai. A school wants to split n students into two photo groups. The height of each student is ai. The two groups must be non-empty. A group is called good if the difference between the tallest and shortest in the group is at most d. Determine whether it's possible to split all students into two good groups. Constraints: n is lesser than 1000 and greater than 2, like greater than or equal to 2 and lesser than or equal to 1000. D is in between 0 and 10 power 6. AI is between 1 and 10 power 6. D is the what are the difference between shortest and tallest. And then we have AI, which is the height of each student. Basically it's an array, I think. Yes, it is an array we have taken. Now we'll just try to understand this question in simple terms. So imagine a class with a bunch of students. To be called as a good group, to be called as good, the difference of height between height of tallest and the height of shortest should not exceed d. Should not exceed d. That is all as what they have asked us. So can we actually try solving it? How are we gonna try solving it? So if we just think of the naive approach, if we just think of a naive approach, which seems brain rot to a lot of advanced programmers, but then imagine you are trying the absolute naive approach. We might think that it's easy to try, but then imagine there are 1000 students. So there are what, 2 per 1000 ways you can split them. So it is 100%, like a millionth percent it's gonna give you a TLE. So ignore the name now. We'll find our intuition. Give me a second again. Yeah, so we want the height difference. Actually, we want to minimize the height difference in every group. Basically, that is all we are asked to do. So what we can try doing is we'll sort the group, like sort the heights, and then create subarrays. I think this is too big. And then we can create subarrays. Yeah, this is perfect. And then since we need only two groups, what we'll do is some one line we have to draw. Imagine this is a sorted heights. We have to draw one line somewhere here, so it will divide them with minimum grouping. How are we gonna solve this? We'll just check the approach. It's also, again, as I said, I personally feel that like it was easy, but still I solved C quicker than this, to be honest. Approach, how we are gonna do it is, first, as I said, sort the heights. And secondly, we have to loop through the possible splits. What are the possible points we have? That is, I is equal, from where we are going to do, I is equal to 0 to I is equal to n minus 2. We are gonna loop through all the possible split points here, and then in the next step what we'll do is we'll left group everyone from index 0 to I. Left group, okay, sorry, a small mistake, guys, I'm sorry. Ah, shit. So here what we are gonna do is we are gonna loop through all the points between 0 to I. That is, we can keep it in other words, I from 0 to n minus 2. We'll put it this way. It's a better way of putting it. We are gonna loop through all the possible split points, whichever will come, from I to n minus 2. And then in our next, what we are gonna do now is the left group is where everyone from index 0 to I will be there, and right group, this is for the left, and then for the right group it's I plus 1 to n minus 1. This is my right group. Now what we'll do is we'll check for the condition. What is the condition? Check my condition. Anyone in the chat, what is the condition? For the left group, our height difference should be a of I minus a of 0. And for the right group, it should be a of n minus 1 minus a of I plus 1. The tallest and shortest. N minus 1 is the tallest guy and I plus 1 is the shortest guy in the right group, and a of 0 is the shortest, and the guy at the position 0, the first position is the shortest, and the last final position is that is I for the left group is the tallest person. So we are just gonna take the difference, and then what we will do is, if both of those heights are lesser than or equal to my lesser than or equal to our value d. Our split, we have to print yes, else just print no, else final step, else no. That's all is our approach. Simple. So basically I'll just show you guys the code for a second, you'll understand it better I guess. So we are sorting first and then we are taking the differences. See, basically the difference is this: a of I minus a of 0, if that is lesser than d, and we'll just use another condition, and condition, a of minus 1, that is my final Python. You can use n minus 1 as the minus 1, which is again gonna give you the last element of the array or sub array, and then minus a of minus 1. If both are lesser than d, then we'll print yes, and then we'll just else we'll just return no. That's all as our code for this. A simple question. Again, what is the time complexity of this sorting? I just hope nobody uses bubble sort. So it's O of n log n. It's O of n log n. And the space complexity, blindly store an array O of n. Single array you are storing, so it's O of n. Very easy. So that is all is this question. Honestly, it is a very simple question, but yeah, we need to understand the question a bit. It's not that direct, like, I mean, it is direct, but it's not direct. It's kinda, what do you say, like a anomalous question. To be honest, this seemed I mean, I don't know how I can say this, but yeah, kinda different, like easy but not easy kind of question I felt. So now we'll go to another question, our next question. If anyone has any doubt, please put it in the chat section, guys. And the next question is, I think, the seasonal question: ice creams. I mean, with the summer, I think everyone is wanting to eat ice creams. So I don't see any doubt. So I'm just moving on to the next question. That is, again with Hannah, I think. Yes, I remember it. Yeah, Hannah. Don't know who is this Hannah, but yeah. Whoever it is, I'm jealous of her as she's getting a hell ton of ice creams to eat and not me in this hot 48 degrees Celsius weather I'm staying in. So basically, we'll go to our 10D, that is ice cream. Ice cream. Anyone in the chat, if you guys want, you can sponsor me ice creams. You can just drop me a mail or a text in LinkedIn or any other platforms. I'll definitely give you my UPI or my address. Please drop me ice creams. You can drop a number of ice creams to me, guys. That is the way. If you really want to thank me, guys, please go for it. Ice creams, go for it, guys. So yeah, jokes apart. Now we'll just read the statement. Ice cream. 10D ice cream by Hamid Shafi. Hannah has n ice creams. The ith ice cream has initial volume Vi. Each second the following step happens in order. If all ice creams have volume 0, Hannah wins immediately. Otherwise, if any ice cream has volume 0, Hannah loses. If all ice creams melt, third point is all ice cream melt, so each ice cream loses 1 unit of volume. If every ice cream now has strictly less like the volume is strictly less than K, Hannah will lose. Hannah picks exactly one ice cream with volume at least K and licks it, reducing its volume by exactly K. Determine whether Hannah can finish all the ice creams without losing. I don't know about Hannah, but I will definitely finish it, man. The constraints are n is lesser than 2 into 10 power 5, k is lesser than 10 power 9, and v is lesser than v of I is lesser than 10 power 9. So we need to bring down our time complexity. So our time complexity should be in some n not anything beyond n. So we'll try to understand the question better in simple words. So we'll take that Hannah has, we'll take n ice creams. I'll write ice itself. Every second, imagine every second, 1 second there is, every single ice cream is melting by one ice cream. 1 second, every ice cream, every ice melting by 1 unit, that is decreased by 1 unit. It's decreasing by 1 unit basically. That's what is melting, right? So on top of this, what Hannah is gonna do is, now Hannah can pick one ice cream and she'll lick it. She'll pick one ice cream and she'll lick it. And once she lick it, she'll lick k units here. Once she licks it, she'll lick k units here. So she wins. When will she win? Win condition is all ice creams volume is equal to 0. That is the case where she wins basically. At exact same second, same time. At the same time. Basically, if she finishes everything at the same time, is what? Volume hitting 0. She's winning. So now we'll check how we can solve, like with the basic naive approach, or like we'll just see our naive approach how will go. So she has n ice creams. Every second 1 unit is melting. She picks exactly one ice cream and licks k units of it. But guess which she should lick. Lick which. This is the basic trap here. You can consider this kind of trap. And the volumes is up to 10 power 9. So if you go on finding every single thing, by the time we reach what, some maybe 10 power 4 or 10 power 5, we might hit a TLE. We are gonna definitely hit a TLE if we use this method. So yeah, we'll just eliminate this. Now what we'll do is, instead of simulating this, what we'll do is we'll just try a kind of, okay, we'll try to reverse engineer, we can say it. What we'll do is we'll try to figure out some math, because my personal opinion, I think so 90% of the competitive programmers will agree that if your math is good, you're half done. Not just competitive programmers, if your math is good, your computer science is good. Like, be it data structures, be it machine learning, be it any other domain, if you're whatever, like if your math is good, you are almost half done there itself. So we'll try to get some math. So for Hannah to win, what she needs to do is everything. The game must last how many seconds? T seconds for every ice cream. Every ice. Now, in T seconds, what happens? The natural melting is gonna remove N into T volume across all the ice cream. This is the removed volume across all. Volume removed across all. Now, basically what this says is, what should be my initial starting volume? Also, sorry, I forgot one more point. Now, even Hannah is licking off, and per lick, how much she's gonna remove is 1 second, that is t seconds are there totally, into per lick she's getting 10. So, this is how much Hannah is licking. Hannah removed. We rem by Hannah totally. So, now what should be my initial volume I need to pick of all the ice creams together? V total of all ice creams, what should it be equal to? Anyone in the chat, what should it be equal to? It should be equal to T into N plus K. So our exact time is gonna be here. What is the exact time, guys? Anyone in the chat? Waiting for the chat. Anyone in the chat, what is the exact time that's gonna be here? Anyone, guys, in the chat? A easy question, try, guys. What is my T equal to here? What is my total time, guys? My total time is total volume into N plus K. That is all as my total time. Now, what is my approach I'm gonna use here? Firstly, sum all ice creams to get total volume. Sum all ice cream, sum up all the ice creams, total volume. Second, what we'll do is check if it's perfectly divisible by V divisible perfectly by N plus K. If it is, then what we'll do is we'll check for the check for the target time. If yes, if 2 is yes, in that case what I'll do is I'll calculate the time. Time is equal to V into N plus K. Math, again basic math, but math is everything. In my fourth step, what I'll do here is individual ice cream will check for every individual ice cream. What we are checking here, it must be big enough to survive T seconds of natural melting. So our volume of that individual ice cream should be greater than or equal to T, because it should survive T seconds of melting. This is for melting thing. Now, in our next step, what we'll do is, within the same step, within the same fourth step, what we'll do is the remaining volume, after melting, that is V of I minus T, should be perfectly like equal to whatever Hannah is gonna lick. That is k sized. That is, if we again put some math here, v of I minus t mod k should be equal to 0. That is all it is. Now, if this case is true, if all ice creams pass this, yes, all ice creams pass, then yes, and then else no, else no. That's all, guys. I'll just show you guys the code for this. You'll take the sum total volume, and then if it's not divisible directly, you can print no. Now again, this is we are just checking the modulus value here, and if it is not equal to 0, we are printing no, and if it's then we are returning and printing yes. Basically the main part is here. This 5 lines or 6 lines is the main algorithm, what, like some 7-8 lines. This is the whole algorithm for this question. I hope it's clear, guys. It was kinda tricky, but good question. Again, I liked the question. I would love it if the question sitter sponsors me the ice cream though. What is the time complexity, chat? Come on, chat, think. What is the time complexity and what is the space complexity? In the chat, guys. Basic time complexity is off, and we are just using one single array for calculating the sum, and we are looping through the same array. And space complexity, as I say, the blind method. If single array, it's off, and most of the times, 99% of the times. And then the question E, if anyone comes across the solution, please let me know. I'm gonna watch Shayan's stream after this if he's streaming. I actually could not figure out how to solve E. I mean, I tried some things, but then it was not accurate. It was failing in the second case, like what, like E. I actually am not gonna explain you guys E because I myself was confused with E. But then we'll go to F next. F is pair increment ranges. So these F and G actually were like to show that you are good, bro. You are a CP guy. These F and G were the ones that would show that you are worthy, bro. You are actually worthy to solve. I mean, it's not like the people who didn't solve this are not worthy. Nothing like that. But these questions were literally like. I mean, I liked it again. I don't know. Okay guys, we'll go to our next question, that is F. Pair increment ranges by Hamid Shafi. Again a good question this was. You are given two arrays A1 A2 to AN and B1 B2 to BN. An interval L comma R including both with 1 smaller than or equal to L smaller than or equal to R smaller than or equal to N is called beautiful if it's possible to make AI equal to BI for every L lesser than or equal to I lesser than or equal to R. Using the following operation any number of times, you can use the operation any number of times. Choose an index I such that L lesser than I lesser than or equal to R, then decrease AI minus 1 by 1 and increase AI by 1. This operation affects only the current interval L comma R. For each test case, output the number of beautiful intervals. This is my question now. And then the test cases are between, like, the t value is between 1 to 10 power 4 and n is between 2 into 10 power 5 and 1, and AI, BI are 10 power 9 values, so it should be a good O of below O of n solution basically. Like, we can't do any other stuff. And then the sum is not exceeding 2 into 10 power 5. Anyone, any ideas how we can solve this? So chat, anyone, how are we gonna solve this? I'm first gonna explain this question again if you guys need. So it's basically array A should be converted to array B. We'll just take it as overall. We are allowed to pick an index I, subtract 1 from it, from the left element, that is A of I minus 1, and add 1 to right, that is A of I. We need to find how many. We'll find how many contiguous segments will be there. Subsegments, so that our array is matched. So this is a question basically overall. We have to match, we have to convert A to B matching the arrays. So we have to count how many subsequences, or not subsequences, sorry, how many subparts or subsegments of the array are there. So how we'll do this is, we'll see the intuition. Again, some slight maths is used here again. I mean, at least from my perspective, I use a bit of math here. Don't know, there could be other ways of solving. Anyone in the chat can let me know. So what the operation says, whenever the operation is like subtract from left and add to right, add to right. What we'll do in this case is, it's basically shifting the value. That is, if we look at our difference array di, it will be a of I minus b of I, and we want to make all this like d of I is equal to 0. Basically this is my mission now. Now what we'll do is we'll try calling prefix sums on this difference array. Prefix sum, we'll call prefix sum on difference array. Difference array. So what happens is, our operation, what it is meaning is, our prefix sum p of I minus 1 is subtracted by 1. That is, it's decreased by 1. Decreased by 1. And the segment starting at L and ending at R, this is this possible decrease. What we did, the decrease by 1. When is it possible? It was possible when, only when, a segment is starting at L and ending at R is valid. Only when. Anyone in the chat, when is it valid? There will be two conditions. The first condition is, total sum should be balanced. That is, P of R is equal to P of I minus 1. And the second one is, we should never drop below the baseline. That is, for every kth element inside the segment, every kth, P of k should always be greater than or equal to P of I minus 1. So this is all how we need to solve this. I want the chat to answer my question. Which is the data structure we are gonna use in this case to solve this question? Anyone in the chat, guys, what is the data structure we are gonna use? I'm gonna wait 2 minutes. I'm gonna wait if anyone in the chat is gonna answer. Okay, so we are gonna use our very famous data structure, that is monotonic stack. We'll use monotonic. Why are we gonna use monotonic stack here is, we need to count how many pairs equal prefix sums are existing without any smaller prefix sums being there between them. So to do this in O of n time, what we need to do, we are gonna use our monotonic stacks. So I'll just go quick, I guess the stream is being too long. First step, we'll maintain strictly increasing prefix sum, stack of, maintain stack of, strictly increasing prefix sum alongside frequencies. Alongside their frequencies. Done. In our next step, what we are gonna do is, we'll keep running this prefix sums. Keep running prefix sums as we iterate through the array. Run prefix sums. As we iterate through the array. As iterate through array. Done. Next step. If P drops below the top of our stack, what are we gonna do? if p is lesser than condition, which I said, if p is lesser than pi minus 1, that is the top of the stack, it can never be our starting point. It violates our rule. It's violating our rule, so it can no longer be starting valid point. No longer valid start. I'll just write valid starting. Okay, I'll write starting point. What am I gonna lose? So that's what it is. Now, next step. If our p is equal to the top of our stack, p is equal to our second, one more condition which we had, our top of our stack, top of stack. In this condition, what we are gonna do? We found our valid segment. This implies that valid segment found. Valid segment is found. So, what is our total answer now? We have to first add the frequency. Add the frequency of this whole thing. Of this whole stack. Top. We'll add this to our total answer. And remember that in this case, whenever this condition is, we'll pop it off. I just forgot, I'm sorry for it. Just pop it off. And then after this is done, what we'll do is increment the frequency by 1. Increment the frequency by 1. And finally what we are going to do is, if p is greater than the top, push onto stack, push to stack with frequency of 1. That is all is what we need to solve here. First I'll tell you the time complexity. Everyone knows that monotonic stack O of n. Space complexity again O of n to hold the stack. Now I'll just show you guys the code. If you wanna if you can easily understand it, just try understanding the code. The implementation of monotonic stack, popping whenever the condition is failing, and then incrementing 1. We are checking and incrementing 1, and then finally we are appending those values. So if anyone has any doubts on this question, you guys can let me know. Okay, I'm going to the final question which I solved today. That is G. That is Dynamic Tree Beauty, a question by Bahman Shafaghi. Bahman Shafaghi. And this is again, I liked this question too. So G. Dynamic Tree Beauty. To be honest, this question was a bit hard. I took almost around 30-40 minutes to solve this, and in the end time I submitted it. I read the questions initially, I read all the questions for 30-40 minutes. I was just reading because I was eating my dinner. Only then I got my laptop and then I started to code basically. So I had seen all the questions, and then for this questions I honestly took almost 30-40 minutes. So what is this question? You are given with a rooted tree with n vertices numbered from 1 to n. The root is vertex 1. For every vertex I, with 2 lesser than or equal to I lesser than or equal to n, you are given with its parent pi, it's guaranteed that 1 lesser than or equal to pi lesser than or equal to I. The parents p2, p3 up to pn are given in one line. At first, only vertex 1 is red and all other vertices are white. Vertex 1 always remains red. You are given q queries. The query vertices x1, x2 up to xq are given in a single lane. Each query a vertex x with 2 lesser than or equal to x lesser than or equal to n is given. If vertex x is white, it becomes red. If vertex x is red, it becomes white. After each query, consider always to choose some of the white vertices and color them blue. If w are white vertices, then there are 2 power w such choices. For each choice, define the colored vertices as all vertices that are red or blue. The blue coloring is only used for its calculation and is not kept for later queries. The beauty of the tree is the minimum number of wedges that must be marked so that using only marked edges it's possible to move between every pair of colored vertices. If there is one colored vertex, the beauty is 0. After each query, the output the sum, because sum of the beauty's overall choices of blue colors modulo of 998, 244, 353, basically a large prime number. We are gonna modulo it. It was actually a very complex question. You guys can see the, what do you say for this, the constraints. It's like 10 power 4, 10 power 5, 2 into 10 power 5, and the sum is between, like, it's less than 2 into 10 power 5 and all that. First, let me make you guys understand this question. Give me a second. So this question in simple words, what is this question in simple words? Let's try to understand. We have a tree where the root okay, I'll just try to make it better. Wait. Yeah. Consider this to be the root. And then this is the root. This is node 1. This is always red. And then I'll use another color. Use something like gray. And then there is others which are switching between your red and your white. Is that clear? So what is our beauty here is, beauty equals number of edges to connect all colored nodes. All color nodes. But also there is a small catch here. That is, we have to imagine one thing. That is randomly painting. I'll just edit the same photo. I'm lazy to draw another. I'll take another which is, where is blue, man? I guess this should be okay. Yeah. Now we need to imagine what. I'll draw it again for you guys understanding. This is my root node. Again red. There's a switch between red and white. Is that clear? So now we have to imagine one more thing. That is, there is another beauty across, that is, 2 power w, oh okay, I'll just draw the blue imaginary circles or the nodes. So there are some blue nodes which is equal to 2 pi w, 2 pi w nodes. That is basically this white node was there, right? The same white node is gonna get painted with blue. Initially it was white here, it got painted with blue. So that is what our question says now. So what we need to finally do is we need to calculate the beauty among all the 2 power w possible random blue colorings. 2 power w, I'll write it with blue itself. Blue colorings. Now, first thing, I mean, it's the G question, G, so we all know that if we try applying naive approach, it's not gonna work. So naive, I'll just cancel it out. Naive is, we can't manually calculate this, so just cancel it. I'm not going detailed in that. It's basic. Now, how are we gonna do our intuition? Intuition. What we'll do here is, instead of looking at that whole tree, whatever it is, instead of this, we'll just take one edge. That is connecting a node U to its parent. We'll just take this one case. When is this edge used? Because root is always red. Where is my colors? Yeah, the root is always red. So this is always red. When is this edge used? This edge is used only when at least one colored node is use subtree. That is, we'll just split it to 2 more points. If there is red node in use subtree, the edge is used in, then the edge will be used in all the 2 power w combinations, because it's the root node. And if not, if there is no red nodes in U subtrees, no red node, if there is no red node, what are we gonna do? The only edge that's gonna be used is, it's gonna be used if at least, very important, one of its subtrees white node is what picked to be blue. Only in that case it will be done. So we'll try to derive the math for this. Initially it's 2 power w, and then it's 2 power w minus 2 power w minus s u. So now we'll just go to the approach. I basically used a great data structure which could, if not known properly, could kill anyone's interviews. That is everyone's favorite Fenwick trees. Along with Fenwick trees, it was LCA. LCA plus Fenwick tree is what I personally used first. We are not gonna build the tree and all here, rebuild and all. We'll just track the red. First we have to track the red node. So to do this, what I'll do is I'll calculate the subtree size. The SU. Okay. The subtree size I'll calculate and set up binary lifting. Set up our binary lifting to find, what are we gonna find? LCA, our lowest common ancestor. Lowest and what is the time it's gonna take for this? O of log n time. Now in our second step, what we'll do is we'll be basically dynamically tracking. That is what we are gonna use is use Fenwick tree and it is mapped to DFS. Mapped to DFS. Entry or exit times of the tree basically. Entry or exit. Sorry. Entry or exit times of tree. So what we'll get from this is we'll instantly know this is gonna give me instantly the number of red nodes. I'll write it with red itself. Red nodes I'm getting here. Like how many red nodes are there in the subtree. Done. Next step. When our node X flips to red, X flips red, we use our Fenwick tree. To find closest red. Red neighbors. In our DFS order basically. Is that clear, guys? And then finally in our fourth step, not finally but in our fourth step, we'll use our LCA. We calculate what is the exact path length X adds to the existing red tree. So calculate exact how much path length X adds to existing red tree. We got this. Finally we'll just sum it all up. We add this red path length to our pre-calculated expected values of our white trees, white subtrees. So basically I'll just explain where and what the data structures were used, because this is a very complex question. Data structures used in this. Just gonna explain you guys before going to time complexity and all. Fenwick tree. I said why Fenwick tree was used. It was used because we need to update our nodes color by adding or removing in login time. So to do this, what we are gonna do is like basically to query how many red nodes exist before or after a certain point, we are using how many red exist before or after certain point. So this is why we are gonna use this. And then binary lifting array, our famous sparse table. We are gonna use our sparse table, basically a pre-computed 2D array kind of thing we are using. What this does is this allows us to find the LCA of two nodes in a very fast manner. When a node turns red, we need LCA that's closest, LCA closest red neighbors, LCA with closest red neighbors. To calculate this will give me what? Exact new edges that are activated. And then we are using two array of Euler, that is flattened tree via our DFS. Why we are using, I'll just write it, Euler's two array, also called as flattened tree via DFS. So how it's used is basically we record exact time we enter and exit our node during a depth first traversal. Basically that's all. And why it's used basically is, if we try to query trees dynamically, it's hard. So by flattening trees into a 1D array, trees to 1D array, what happens here? It's basically based on entry exit. Or exit. Sorry. Entry or exit. A subtree simply becomes a subarray. And then a subarray becomes contiguous subsegment, NUOUS, continuous segment. What the segment does is, this is what our Fenwick tree is gonna use to calculate easily. This is basically the whole background process for this. And finally, I'm gonna say you guys what is the time and space complexity for this. The time complexity for this is O of n log n for LCA setup and then O of Q log N for Fenwick. This is actually very fast, like both are logarithmic time complexity, so it's incredibly fast. Now, space complexity. If we are doing a binary lifting table, sparse table, so our space complexity is O of n log n, binary lifting table. Binary lifting table. So I hope that clears. I'm not gonna show this code. I want you guys to code it. Try coding it. Basically, if anyone has any doubts, please go ahead and ask if you guys have any doubts. I had got some retracted messages. Sure, I'm gonna inquire about them. So it was a good 1.5 hour stream. I guess that is all from my side. Please, if anyone can get me the final, like the 5th question's answer, let me know, guys. And that's all. It's me signing off from the stream. Thank you everyone whoever joined the stream. We'll see you soon with another brand new live stream. I don't know when, I don't know how many days of break. I'm not gonna say that I'm gonna stream today or tomorrow, that I'm definitely gonna miss. So we'll see when I'm gonna stream again. With this, we are officially ending our stream. Thank you everyone who joined, and thanks a lot for everyone who are gonna watch it recorded later. And then again, a big shout out to Cheyenne and his whole team for amazing platform Repovive. Awesome, man. It's an awesome work. I mean, keep going. All the best for them too. With this, I'm gonna end my stream, guys. Bye bye. Take care.